So far in this class, we've only been talking about solving equations with one variable, like 2x plus 3 equals 4 or something like that. And in that case, you can find the one answer that works. But sometimes equations might have multiple variables. And so like this equation right here, y equals 2x plus 3, this equation has infinite solutions. I could plug in any number for x and get out something for y. Like I could plug in a 1 for x, like if let's call this x and this y. If I plug in 1, I'll do 2 times 1 plus 3, and that gives me 2 plus 3, which is 5. So when x is 1, y is 5. That is one of the combos that makes this equation work. When x is 1, y is 5. But that's not the only one. Like when x is 2, so plug in a 2 for x, y is 4 plus 3, which is 7. So 7. When x is 2, y is 7. I could plug in 100. When x is 100, I get 200 plus 3, so 203. Whoops, 203. So when x is 100, y is 203. I could even pick some y values, like let's say y is -1 or something. So when y is -1, we could solve for x by subtracting 3 and then divide by 2, and we get -2. So when y is -1, x is -2. All of these points, all of this infinite number of points, if we put them on a graph, like I'm not going to be able to just put it on a number line because I don't just have one number. I actually have two different numbers that form pairs, what we call ordered pairs. And so to graph it, I'm going to need a number line for the x values and a number line for the y values. And that's how a coordinate grid is formed. You might call this the xy plane or a coordinate grid. And basically it allows us to plot these coordinates like we were graphing them on two number lines at once. Like if I go to where x is 1, so if this is the x-axis, go to where it's 1, and go to where y is 5, and see where those two things meet up, that happens right here. If I go to where x is 2, and where y is 7, that's right here. If I go to where x is 100, way that way, and where y is 203, that's way up there. And so since this line goes forever, we put arrows on the ends to indicate it's going to keep going forever in both directions to infinity. All right. I know there aren't like actual points here, but each point on this line, a line is just a collection of a bunch of points that are all so close together you can't even see it. And all these points, even the ones that are like decimal values, like 1.6 and 6.1, that would make this equation true. So this line is literally a visual representation of all the solutions to that equation. So for example, if I asked you, is the point 1, 0 a solution to this equation? And this is a graph of that equation. You could immediately tell me no, because 1, 0 is right here. It's not on the line, so it's not a solution. You could also plug it in, plug in 1 for x, so 2 times 1 plus 3, which is 5, not 0. So that's another way I could tell it doesn't work. Okay, so what happens if I add in another equation or another line? When you have multiple equations, we call that a system of equations. Often you'll see with two variables you have two equations, but there could be more. So to solve a system of equations, you basically need to find coordinates that work for both equations. So it has to be a solution to this line and to this line. It has to work for this equation and this equation. And usually that only happens one time. Like this equation is going to have infinite solutions. This equation has infinite solutions. But if we're looking at what works for both of them, that's pretty rare. This is actually very easy to do on a graph. Because remember, this blue line represents all of the solutions to this equation. And this red line represents all the solutions to this equation. So if I want to know what works for both, well, that's this point right here. The point 2, 5, see, 2, 5. Because it works for the red one and it works for the blue one. So all you have to do to find the solution to a system of equations, like if you have multiple equations, you just look for where the graphs intersect. Typically with lines, that's only going to happen one point. So there are no other points that will work for both equations. If I picked a point like here, it would work for the red one, but it wouldn't work for the blue one. If I picked a point like here, it would work for the blue one, but not for the red one. This is the only point that works for both. Like I said, you can have more than two equations. Like this is 1, 2, 3 equations, and they all meet at the point 1, 1. As long as they all meet up at the same point, then that's the solution, 1, 1. Note that the solution here is actually two numbers. It's an x and a y, and that's called a coordinate or an ordered pair. You do need both an x and a y for your one solution. So let's look at another example. Go ahead and pause and see if you can figure out what the solution is to this system of equations here. So again, the solution's just where they intersect, which is right here. -2, -1. That's it. Sometimes you'll see this written out as like x equals -2 and y equals -1. These two things mean the same thing. So if you ever see it written like this instead, just know that it's the same thing. Again, it's just one solution, the ordered pair -2, -1. This time we're going to have to graph ourselves. So if I want to solve this system of equations, that means find a point that works for this one and for this one. So you're going to need to remember your graphing skills here. Remember, if you're graphing a line, you always start at the y-intercept, which is the number by itself. This is the y-intercept. So this is where it hits the y-axis. The constant tells you where it hits the y-axis. So 3 is right here. Basically, if you plugged in a 0 for x, you would get out 3, and so that's why it hits there at 3. And then you could pick some numbers for x and see what you get out for y and plot those points. Or you could just use this as the slope. The number in front of the x is the slope. Remember, that's like the rise over the run, how much you go up versus how much you go across. In this case, it's -5, so we're going to go down 5 over 3, so we're going to go over 3. So go down 5, -1, 2, 3, 4, 5, over 1, 2, 3, in the positive 3 direction. And that forms a line. Feel free to use a ruler or a straight edge of some kind. My line was a little rough there. On this one, our y-intercept is -3. And so that is here at -3 is the y-intercept. And then the slope is 1/3. So go up 1 over 3. Up 1 over 3. Oh, look, there it is. Up 1 over 3. Whoops. So that right there is my solution, because that's where they intersected. So 3, -2 is the solution. Okay. The question now is, actually let's just graph this and see what happens. This one has a y-intercept at 3, and the slope is -1/2. So go down 1 over 2. Down 1 over 2. Or you can even go backwards, back 2, up 1. Make sure you put arrows on the ends of your lines because they do continue forever. This one has a y-intercept of -1, and it also has a slope of -1/2. So down 1 over 2, down 1 over 2, and vice versa. So what do you notice about these two lines? They're actually parallel, meaning they go right next to each other. They're the same distance apart at each point, and they're never going to touch. That happened because they have the same slope. And so since they have the same slope, they're literally sloped the same way, and so they're never going to touch each other. If that happens, where's the intersection? In this case, there is no intersection. They're never going to cross, and so there's literally no solution. And that's not like 0. 0 is a number. This is literally, there is no solution. There is no number that I could come up with that would make this equation true and this equation true at the same time. It's kind of interesting. So keep that in mind. Anytime you have parallel lines, which basically they have the same slope, there's no solution. That happens sometimes. And let's go through one more example here. Yeah, this is it. Last one. So for this first line, we start at positive 1. That's our y-intercept. Be careful with the slope here. We're not just going up 2, like we're not just going up 2, up 2. We're actually doing 2 over 1. So you'll go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, and then this one we're going to need to simplify a bit. So when I simplify it, 5x minus 3x is 2x. 10 minus 9 is actually just 1. So notice, I actually got the same equation that I got originally, that I had originally. This line is literally the same line. It's right on top of it. So what is the intersection here? Well, the intersection is literally the entire line. So every single point on this line is a solution to both because they're the same equation. So basically the solution is anything on this line. And what we typically say in this case is that there are infinite solutions. Like, I can't list them all, there's infinite. It's everything on the line because they're actually just the same line. So there are infinite solutions. So if they're ever parallel, there's no solution. If they're ever actually just the same line, there's infinite solutions. And that's pretty much it. Other than that, you could only have two lines that intersect once. So there's either one solution, infinite, or no solutions. I do want to mention one final thing, which is if you ever get an equation that looks like this, this equation doesn't have an x in it. It's just y equals 3. This is still a line. Think about, in this case, 3 would be our y-intercept, so we'd go up to 3. We'd literally go to where y is 3. And then imagine we were like making a table of x and y values. If I plugged in 1 for x, what would I get out for y? Well, y is 3. If I plugged in 2 for x, y is still 3. If I plugged in 100 for x, y is still 3. Literally, y is 3. So if I start graphing these points, 1, 3 would be here, 2, 3 is here, 103 is still along this line. You'll notice that it forms a horizontal line. So anytime you get something that's just y equals a number, it's going to be a horizontal line. Just look out for that. It doesn't have a slope of 3, it's literally just 3. No matter what x is, y is 3. If you ever get an x equals a number, like x equals 3, go to where x is 3, which is here, and also here, because this is 3, 1, and 3, 2, and 3, 3, and 3, 4, and that forms a vertical line. So if you ever have x equals a number, it's a vertical line.